Okay, so this is day 2 of our STAAR review. Okay, day 1 was over Pythagorean theorem. I sent that link out on Remind yesterday. I'll send this one out this afternoon, as well as a link to a playlist. I'm going to have a playlist of all of the STAAR review, so that way, if for some reason you don't sign up for Remind until Thursday, you can still access that playlist, and you'll have, all the videos there. Today, I feel like this lesson is going to be every bit as important as Pythagorean theorem. I think you guys saw how often this came up when we did our benchmark. Maybe not as much as Pythagorean theorem, but maybe one question less. And that is transformations. The only reason that I would say Pythagorean theorem is more important than transformations is because Pythagorean theorem is easier. Pythagorean theorem should be automatically we get those questions correct because it's very simple. Transformations can be tricky. Okay, so because of that, transformations, I'm not going to put as much pressure on you as I will for Pythagorean theorem. But that being said, we know that transformation questions are going to be on the test. All right, we know that they show up quite a bit. Okay, and so if you're going to really prepare for something, this is definitely one of those things that you want to prepare for. Okay, so let's talk about the different transformations. We'll start out with the easiest ones first. That would be translation. A translation is when we slide a figure or a point. Okay, what that means is we'll move it either left and right, up and down, or more than one direction. Okay, it could be along a diagonal line. Okay, so an example would be if we were to have this coordinate grid. Let's say we had this right triangle. If I did a translation up and to the right, well, let's do it right here. Okay, that right there demonstrates a translation. Okay, it did not rotate at all. It didn't. The shape itself looks exactly the same. Okay, it's the same size. It's the same shape. It's just a different location. Okay, so I'll write that over here. Same size, same shape, same orientation. Only thing that is different is the location. Okay? So that's the big thing there. On a translation, the only thing that changes is the location. Now, one of the ways that STAAR test can ask you about this, okay, is when they're talking about same shape. They may not say same shape. Okay, obviously they can say congruent, but one of the things they like to say is the angles will be the same. Okay, if you have a shape and you change the angles, is it still the same shape? No. Okay, so when we say same shape, we mean the angles are all the same. Okay, so if they give you a question where like it says, which of these statements is false? And it says that translation changes the angles, you know that's false because translation gives you the same shape, therefore the angles can't change. Okay, so when we do translations, a lot of times they'll say, you need to translate this figure 3 units up and 2 units left, or something along those lines. Okay, and you could, on a coordinate grid, we could literally count those directions out, and we'll move every single point. Okay, one of the things that we need to make sure that we identify is the pre-image and the image. Okay, the pre-image is what we started with. The image is what we ended with. Okay, and that's something you probably remember. Okay, and so looking at this, really, you guys do pretty well with transformations when it's just graphing the transformation. All right, or identifying which is a graph of the transformation. Okay, where they tend to get us is when they get into the algebra representation. Okay, and so that's really, we're going to look at that a lot today. Okay, the algebraic representation is where they say something along the lines of, okay, for a translation, if you have x and y, we're going to transform that point by saying x plus 2 and y minus 3. Okay, well, the x coordinate deals with left and right movement, right? Correct, I should say. All right, so if we're adding 2, is that going left or right?
Right.
Right, so this is right 2. And y minus 3, how's that going to move us? Down. Y is up and down, so if we're going to subtract 3, then that's going to be down 3. Okay. If we were to say x and y, we'll do x minus 1 and y plus 10. Okay. X minus 1 would be left 1, and y plus 10 would be up 10. Simple enough, right? Okay, so a basic STAAR question could be to give us a transformation like this, show us the transformation, and then ask which of the rules represents that transformation. Okay, and I'm going to tell you right now, translations are easy, so we're probably not going to see a whole lot of them. Okay, you might see 1, maybe 2 translations. Okay, but we've got to remember that when it comes to algebra, translations are when we're going to add and subtract, all right, to move left, right, and up and down. Okay, the way you remember that is addition and subtraction is the first thing you learned, right? Whenever you got into math. You learned how to count, and then you did addition and subtraction. Okay, translations are the first transformation you learned. All right, the easiest operation, addition and subtraction, pairs up with the easiest transformation. All right, and we'll do more examples of these, but it's just something to make sure you understand. Now, that's the first transformation. The next transformation, all right, is going to be a reflection. Okay. A reflection is when we're going to flip our figure. Okay. I'm only going to talk about flipping over the axes on this lesson. We talked about being able to flip over other lines. I'm not going to worry about that today. Okay. Since we're just covering basics, that's what I'm going to worry about. All right. So when we're going to flip a figure, okay, we're going to make it to where we mirror it over one of these two axes. Okay, you have your y-axis, you have your x-axis. Okay, and those are always labeled for you. Okay, so getting those mixed up, there's really no excuse. All right, because they tell you which ones they are. All right, so if we had this triangle and I wanted to reflect it over the x-axis, all you have to do is say, okay, well, instead of going up by 1, I'll go down by 1. Instead of going up by 1, I'll go down by 1. Instead of going up by 3, I'll go down by 3. You do the exact opposite. All right, and what you end up with is the same shape, just reflected over that line. Okay? So, just like we did last time, let's look at what changed. Did the shape change?
Nope.
No. Same shape. Which means it has the same angles, right? Nothing about the shape itself has changed. If it was a square, it's still going to be a square. All right? Has the size changed?
Nope.
Okay. So same shape, same size. That means it's congruent. Okay. Has the orientation changed?
Yes.
Yes, the orientation, if you've forgotten that word, the orientation is how it stands. All right, and we can see that it became upside down. Okay, and then obviously, yes, the location did change as well. Okay, and I'm not going to write that down. The only reason I wrote it down on translation is because that's the only thing that changed. Okay, let's say we had this triangle here. All right, if we reflect that over the y-axis, all right, I always get a lot of kids that get confused because it's straddling that y-axis, right? But you can still reflect over that axis. You just, instead of going left, I'm going to go right. You know, instead of going right, I'm going to go left. And so what ends up happening is you get this shape there. Okay, so we can still do reflections if the shape is going over the axis we're reflecting over. Okay, now, again, we need to know that this is the image. This would be the pre-image. Oh, no, I'm sorry, that's the other way around. I started at the top, I forgot. So this is pre-image, because this is where we started. And then we ended up down here. So the result is always the image. All right, now, I'll say this. When it comes to graphing reflections, you guys do a great job. All right? I think if I were to get the homework out of the filing cabinet there, most of y'all made hundreds whenever it came to actually doing the reflections. All right. Again, it comes down to the algebraic representations, and those tend to blow your minds. Okay. And I will say that reflections tend to be tricky. Okay. So in an algebraic representation, okay, we're going to look first at reflecting over the x-axis. And then over the y-axis. Okay. If we're going to reflect over the x-axis, then that means we're going to take our original points, x and y, and we're going to flip the sign on the opposite coordinate. So if it's the x-axis, we're going to flip the sign on the y. If we're flipping over the y-axis, we're going to flip the sign of the x coordinate. Okay, we always do the opposite. All right, and that causes a lot of confusion for two reasons. First off, because you would think flipping over the x-axis means change the sign on the x. But it's opposite of that. Okay, so flipping over the x-axis, you change the sign on your y. Flipping over the y-axis, you change the sign on your x. And the second reason that this confuses a lot of 8th graders is because the way that you write this out, 8th graders think that you just make it negative. All right? It's not just make it negative. It means to change the sign. So if y started out as a -2, it's going to become a +2. Okay? So let me write that example out. Let's say that my original coordinate was -1 and -3. Well, when I reflected over the x-axis, my x would stay the same, but my y would change its sign, so it would become a +3. Okay? If I were to do that over the y-axis, let's say my starting coordinate was, we'll say 2, 0. Well, if I reflect over the y-axis, my x sign is going to change, so it's going to go from positive to negative, and my y coordinate is going to stay the same. Okay? All right. When y'all did your benchmark, and this is one of the reasons this is great, is it asked which of these shows, or which of these algebraic representations, and they gave you 4 things that look like this. It said which of these demonstrates a 90-degree rotation counterclockwise. And those are tricky. We're going to get to those in a minute. But let's say you don't know which of them is a 90-degree. You can't remember that one. If you can remember reflection, 2 of the answer choices on that problem were reflections. 2 of the answer choices were this one and this one. And if you knew enough to look at that and say, okay, well, that one is a reflection over the y-axis. and that one is a reflection over the x-axis, then you can eliminate those because you know that they're not rotations. All right? And so now, without even knowing the rotation algebra, you've got a 50-50 chance of guessing it right at that point. Okay? So we definitely need to know how to do translations because those are super easy. We need to figure out reflections because once you understand those and you remember that it's opposite, those aren't too bad. Okay? Dilation is super easy. We'll get to that last. But then rotation, which we're going to talk about right now, is a little bit tougher. Okay, so are there any questions over reflection? Okay. Again, translations and reflections, you guys did a pretty good job on. All right, so the one that I hate. That's right. I don't know. I started writing reflection again. Rotations. I hate these. These are awful. All right. Rotation, there's no trick to remember what it is because it's a rotation. I think most of y'all know what rotate means. So, with rotations, the things that you need to remember, all right, is the direction of certain rotations. Okay, if you rotate this way right here, that would be clockwise. All right, if you went this direction, that would be counterclockwise. Okay. If this blue line is our starting line, then that would be 90 degrees. And that would be 180 degrees. Okay. I'm not going to worry about 270-degree rotations. All right. Now, as far as a demonstration, let's say you had, well, let's do this. All right. We're going to rotate all of our points around the origin. Okay, now if you remember, I told you it's easier to rotate the path than it is to rotate the shape. Now, you could always rotate your paper and see what it should look like. Okay, and I can't demonstrate that on a video, but you could literally rotate your paper 90 degrees and see what the image should look like. Okay, or if it's an 180-degree rotation, you could rotate it 180 degrees and see what you should be getting. Okay, it's a really quick and simple way of checking yourself. All right, but if you want to actually plot each point, all right, the algebraic representation is honestly the easiest way of doing it. Okay, but if you want to actually do some hard work, you could start at the origin, okay, and you can draw a path to each point. All right, so let's say I went here and here. So I have this path. Well, I can rotate that path. Let's say I'm going 90 degrees clockwise. I can rotate this path 90 degrees clockwise. Now I'm going to go down and right. Okay, and if y'all remember, this is the one where it starts to look kind of like that Nazi symbol. Okay, because rotations are evil. All right, so that's how you can make sure that you're going in the right direction. But we end up going down and over. Gosh. All right, instead of here and here, we would go here and here. Instead of over and up, we would go down and over. Okay, and we end up getting a shape, something like that. Okay, which takes that shape and rotates it 90 degrees. Honestly, I feel like that's the harder way of doing this. I really do. Okay, I think rotations, one of the reasons I don't like rotations is because it's the only transformation where graphing it is the harder way of doing them. Okay, I think the algebra representations are the easiest ones. There's 3 different algebra representations. There's 90 degrees clockwise. There's 90 degrees counterclockwise. And then there's 180 degrees, which I need to give myself more room. There's 180 degrees. Now notice I didn't give myself a whole lot of, I didn't put clockwise or counterclockwise on 180 degrees. That's because it doesn't matter. If you go 180 degrees clockwise or 180 degrees counterclockwise, you're going to end up in the same place. All right, so here's our algebraic rules for these situations. If I start with x and y on 90 degrees clockwise, anytime it's a 90-degree rotation, my x and y are going to change positions. They're going to swap. Okay? X becomes y, y becomes x. If it's a clockwise rotation, the x is going to change its sign. That's two things that you got to remember, and it's weird. I know that. I know that it's weird. All right. For a 90-degree counterclockwise rotation, you say x and y becomes, again, it's 90 degrees, so x and y are going to change shape, or change sides. All right. And this time, since it's counterclockwise, the y changes its sign. And finally, for 180 degrees, it's not a 90-degree rotation, so x and y are going to stay in the same places, but both signs are going to change. All right, that's a lot to remember, and I know that, okay? But I promise it's worth taking the time to memorize that. All right, especially going into STAAR test. When you're rewatching this video, when you're taking notes, whatever you need to do, this is one of those things that it's worth investing that time to have this memorized. Okay, because they don't give this to you on the formula chart. You just have to know it. All right, and I really do think it's worth your time. And I think that it makes things easier because let's say you had these 3 points. Okay, we'll say this is -1, 1. And this is -3 and 1. And this is -2 and 4. Okay, let's say those are my 3 points. If I can remember my rules, I don't have to draw paths. All right? I can just use my rule. Let's say I'm going to rotate these 3 points, this triangle, I'm going to rotate that 90 degrees counterclockwise. Well, I know that my x and y are going to change positions, and my y is going to become negative. Okay, so -2 and 4 is going to become -4, -2. This will become -1, -3. This will become -1 and -1. All right, I can see that they're going to swap places, and the y becomes a negative. If the y was already a negative, it would become a positive. We're just changing that sign. And so now that I know those new points, I could say -4, -2. And that would go here. -1 and -3. And that would go here. -1 and -1. That would go here. And that would give me something like that. Okay? So rotations are definitely the hardest transformation. Okay? But once you learn those rules, it really becomes a lot easier. All right, now, with rotations, did the shape change?
No.
No. So the angles all stayed the same. Did the size change?
No.
No. So again, it's congruent. On these first 3, translation, reflection, rotation, they all stayed congruent. Okay? The location changed. What about the orientation? Yes, it's now standing on its side, okay? The only time the orientation wouldn't change is if we rotated 360 degrees, because that takes us right back to where we started. Okay? All right. So that's rotation. Now let's look at the last one, which I really think is one of the easier ones, dilation. A dilation is where we're going to make our shape bigger or smaller. Okay? We're going to dilate the image to make it bigger or smaller. All right? Dilations use what's called a scale factor. All right? A scale factor is what we're going to multiply by to make that shape bigger or smaller. Okay? So, we're going to take that scale factor and we're going to multiply every point that we have by the scale factor. Okay, so if I had a scale factor of 1, what's going to happen to my shape? What's the result going to be?
Nothing.
It's going to disappear?
Oh, no. It's going to stay the same.
It's going to stay the same. Same shape. Okay?
That's what I meant. Like, nothing would happen.
Yeah, it's going to become the same shape, right? So, if we multiply every coordinate by 1, obviously, nothing changes. Okay, what if it's a number greater than 1?
It'll get bigger.
Get bigger. Okay, so if it's 1.5 is our scale factor, we know that that shape is going to get bigger. Okay, most of the time in STAAR testing, they're going to use keywords like double the dimensions or triple the dimensions. That would give you a scale factor of 2 or a scale factor of 3. Okay, if it's less than 1, it's going to get smaller. Okay, now these scale factors are going to be fractions, things like 1/2 or 0.5. Okay, a quarter of the size, which would be 1/4 or 0.25. Okay, and we'll multiply each of the points by that decimal or that fraction. Okay, you cannot have a scale factor that is 0 or less. Okay, because if you multiply all the coordinates by 0, it's just nothing, right? You're going to get 0 for everything. Okay, so you can't have a scale factor of 0. You can't have a negative scale factor. Okay, does that make sense? Yeah. Okay, so if we have a dilation of that triangle, it's going to end up being something like that. Okay, and the way that I taught y'all to check yourselves is to draw that line through all the corresponding points. All right, and you can see I kind of drew this one sloppy because it didn't work out the same, but it should all go through the origin. Okay, but as a result of the dilation, do we have the same shape? Yes. Okay, which means we have the same angles. On all 4 transformation, the shape never changed. Okay, the angles never changed. If they give you a which of these is false question, changing of angles is always going to be false. Okay? You cannot change the shape in a transformation. Doesn't matter what transformation you're doing. You can do all 4 transformations at the same time, and the shape itself is going to stay the same. Now, this time, the size did change. All right? The size changed, and because of that, it's no longer congruent. Okay, so this is the only transformation where we didn't end up with a congruent shape. Okay, did the orientation change?
Yes.
No. No. Did it rotate?
Oh,
No. If it was standing up tall, if you dilate it, it's still going to be standing up tall. It's not going to change the way it's standing. Okay? All right. The other good thing about dilation is when we look at the x and y, the algebraic representation, it just becomes Sx and Sy, where S is that scale factor. Okay? So if you saw that right there, what type of transformation is that?
Dilation.
It's a dilation, but how are we dilating? What's happening?
It's getting bigger. 3 times bigger.
It's getting triple the size. It's 3 times bigger. Okay? All right, so should be simple enough. Okay? All right. So here's what I'm going to do. Again, just like yesterday, I'm going to write out some examples, and I'm going to pause it. I'm going to give you a chance to answer some of these. All right, let's say we have... All right, so you have 5 transformations here. Okay, I'm going to pause the video. Okay, if you're watching at home, you need to pause it yourself. Okay, and I'm going to give you time to come up with the 5 transformations that I just wrote out. Okay, all right, so pause the video. Okay. All right, I'm just going to tell you what they were. All right, and we'll see how many of these you did get correct. Okay, so for x, y, for both signs to change, that would be a 180-degree rotation. All right, for x and y, with the x becoming negative, that would be a reflection over the y-axis. All right, x plus 3 and x minus 2, this is a translation. We're going to go right 3. I'm sorry, this is supposed to be a y. And down 2. So hopefully that didn't mess everybody up. Negative y and x. Okay, I can see that they switched positions, so I know that that's a 90-degree rotation. All right. The y is what changed its sign, and so I know that it's counterclockwise. And the last one is, it's a dilation. It's half the size of the original. Scale factor would be 1/2 or 0.5. Okay. All right. Again, I just want to stress that I think that this is an important thing for you guys to study. There is things to memorize here, and I do think that this is one of the few things in math that spending that time to memorize these things could really pay off in the long run. If you were able to get all of these questions and all of the Pythagorean theorem questions, all right, then, you know, that's a 1/6 of the test right there. Okay, so that's a large portion. Okay, so I really think that it's good to take the time to memorize this stuff.